I'm Valerie.
I'm Katheryn.
And I'm Lisa.
And our project is the Webcor tool loss. Today we will be going over our project background, problem statement, our project scope, our project design and analysis, experimentation and implementation, our results, and further recommendations that we have.
So who is Webcor? Founded in 1971, Webcor is a commercial construction contractor headquartered in San Francisco, serving construction projects all throughout California, making them one of the largest builders in California. Paramount Builder Supply is a branch off of Webcor, and they supply the necessary tools for all Webcor's projects and its workers. Paramount's warehouse, in which all the tools are stored, is located in Oakland, California. This is where tools are being shipped from and returned to at the completion of each project.
So our project problem. Currently, Webcor Construction handles a numerous amount of highly valuable and crucial tools that often get misplaced, broken, or stolen, and suffers a great financial loss from these circumstances. Some projects have a reported financial loss of up to $98,000. Over the years of 2016 and 2017, the grand total of lost and stolen tools across all Webcor projects reached over $1.9 million.
Our objectives for this project include designing a system to reduce this financial loss, as well as improving on-site employee communication. To ensure we design a solution that works well, we will focus on increasing communication between warehouse employees and job site supervisors, preventing theft and vandalism of tools, reducing financial losses, creating a system to increase knowledge of tool whereabouts and worker accountability.
The current state of Webcor's tool tracking system is that there is no system to keep track of where the tools are going when they are grabbed out of the gang box at the beginning of the day. There is also no way to keep track of who is taking the tools out of the gang box. Workers are supposed to check tools on a weekly basis, but this step often gets overlooked due to no accountability. From our construction site visits, we observed that one of the sites, the gang box was left wide open, unlocked for accessibility for anybody. At another site, the gang boxes were locked with a combination or key only given to head workers. This is an inconsistency in their current system. Webcor has also developed a phone application that scans a tool's barcode, but this application is not being utilized.
A flow process chart was created to identify the processes of where a tool goes in any given day and where and when in the process were tools labeled as lost or stolen. We can see that if tools are not returned to the gang box at the end of the day or when the foreman checks at the end of the week, the tool is then labeled as lost. If a gang box is clearly broken into where the lock has been tampered or if clear damages on the box are seen, then any tools are supposed to be in that specific box but is not will then be labeled as stolen.
We began our root cause analysis by creating a fishbone diagram with possible reasons contributing to the tool loss issue for Webcor. This allowed us to brainstorm matters in a structured way. The reasons are lack of communication between foremen and workers, no proper training of workers, workers not accountable for tools that they check out, there's no standardized process, there's no tracking system for the tools, and there's no tracking for worker accountability. Gang boxes are left unsupervised in a high volume environment. There's no set place for each tool. Tools are handled without care, and they are not being properly put away after being used. Doing a 5 why analysis helped us narrow down our project scope and reasons for Webcor's tool loss. We started with why are tools being lost or stolen? Because there's no security or surveillance and tools are not getting placed back into the gang boxes at the end of the day. Then, why aren't tools getting returned at the end of the day? Workers do not feel responsible for the loss of tools, so they place them anywhere. Why don't workers feel responsible for the loss of tools? There's no way to track the tool to the worker if lost. Why is there no tracking for the tool? The workers do not check out the tools when they need to use them. Why don't the workers check out the tools when they use them? There's not anywhere or anyone can check them out with. Doing this, we learned that there needs to be a sense of responsibility from the workers to get their tools back into the gang boxes, and that there needs to be some kind of supervision to keep the workers accountable.
A survey was sent out to project managers, and they were asked to rank the top 3 causes for tool loss based on the reasons we got from performing our root cause analysis and fishbone diagram. Based on the responses from 13 projects, it was found that 53.3% of project managers chose tools in high-volume environment with little to no supervision as their top reason. 26.6% chose workers are not accountable and there is no standardized system as a top reason. 20.1% chose tools not being properly put away after use, and no proper training of workers as the top reason.
Through our research and several literature reviews stood out in coming up with the solution for the problem. In summary, two of the most prominent solutions for reducing financial loss include an RFID system and a construction equipment tracking system. The RFID system is a commonly used solution to address the problem of tool loss that occurs on many construction sites. This system is implemented that successfully identifies the tools inside a toolbox each time the door to the game box is closed. This develops a program to monitor and manage the system throughout multiple storage locations. Out of 50 tools that were tagged, the system had 94% accuracy with a 10-second read and 98% accuracy with a 25-second read. Another system that is used is a form of a construction equipment tracking system. The system sets accountability by being able to track who, when, where, and how the tools are being used last. It is also similar to a library check-in and check-out system because it identifies the employee, the job, tool, and when the tool was returned. Thrasher Basement Systems, a contracting company, was able to reduce their tool expenses by 25% by having any type of tool inventory management. Company workers even say training was minimal and easy to follow.
Based on our literature reviews, we found that the manual check-in system and RFID system are the two most commonly used tracking systems in the construction industry. The manual check-in system would involve assigning a worker who would be in charge of keeping the game box locked at all times and checking workers and their tools in at the beginning and end of the workday. For the RFID system, RFID tags would need to be purchased for all the tools Webcor owns and a reader per project to track the tools at a real-time rate while they are being used on the construction site.
From Figure 1, we can see that for the 500 Folsom Block 9 project, there were already 92 tools that were labeled as lost or stolen out of the 1,943 tools that were issued in 2016. The total financial loss also reached over $37,000 during this period of time. From our research, the average RFID tag costs approximately $22 each, so if we were to put an active tag on all the tools issued, it would cost approximately $42,000. The overall cost for implementing an active RFID system would cost approximately $44,000, but once tools have the tags attached, these tools can be issued to other projects as well as not being limited to one project. So this cost would differ for each project based on whether there would already be tools that have the RFID tags on them. In Figure 3, we can see a projected cost analysis if a manual tracking system were to be selected. On average, it would take about 20 minutes to have one person check out the tools at the beginning of the day and approximately 5 minutes to keep track of all the tool returns. From the data provided by Webcor, the average wage of a Webcor laborer is $22 per hour. This would mean that if a worker were to be selected to be the tracker, it would cost approximately $9.17 per day of non-value added work. And for this particular 500 Folsom project, it would cost an average of $3,300. We also assumed that there would be 10 workers who would have keys to game boxes after speaking to project engineers on site. So this would result in a cost of approximately $33,000 of non-value added work. This cost is not providing additional wages to workers, but they would have an additional responsibility during their workday that will set them aside from performing value added work. As we can see from the cost analysis, an RFID system would cost more to implement initially when compared to a manual tracking system. Another survey was sent out to all project managers and engineers across all Webcor projects. They were asked to rank on a scale of 1 to 10, with 10 being the highest, which factors they believe were most necessary to the solution and what they would like to see in the proposed final design. The factors included cost, time spent, ease of use, reliability, storage space, and accessibility. The weight was then determined as an average from the ranking we received from project managers and engineers. A weighted decision matrix was then created to analyze which system would be the better solution to the problem.
Based on our cost analysis, decision criteria matrix, and speaking to project managers that wanted a system that was easily simple and can be implemented quickly, we decided that a manual tracking system was the most feasible solution for our group to implement and gather results on. We visited the 500 Folsom Block 9 construction site in San Francisco. The project is the concrete base of a residential building. We checked in and out tools at the beginning of the workday for one game box. We also timed how long it took to distribute the tools without a system, which only took about 5 minutes. For the check-out system, we took down the time checked out, name of worker, tool name, and tool barcode, and the time the tool was checked back in. The workers came in a span of the first 20 minutes to receive the tools needed for the day. This does not mean that it took a total of 20 minutes to complete the out process, since the workers came sporadically. It also took us a little bit of time to identify the tool and the worker, whereas a foreman doing this job would already know these things. At the end of the day, it only took a total of 5 minutes to check in all the tools.
Some of our implementation results are: we noticed that the same worker who checked out the tool in the morning was not the same one who returned it at the end of the day. Despite this, all those tools were still returned with the check-in, check-out system. We noticed that the tools were passed around by workers throughout the day. The workers could come back to trade or grab new tools whenever they pleased, and workers other than the foreman knew the lock combination or had the key to the gang box.
After implementation, we received feedback from Webcor. Our further recommendations for Webcor will include having laminated sheets from the warehouse manager. These sheets will be sent along with the gang box, detailing exactly which tools are provided in the gang box, as well as columns for checkout names and time, so the worker in charge can easily write down the names next to the tools. These sheets will be kept locked inside the gang box to prevent workers from changing anything without permission. Another option is to have worker trade cards, where each worker will have a limited set number of their name cards and would be able to trade these cards in exchange for a tool that they need to use. At the end of the day, workers would return the tools and get their name cards back. In order to leave the job site, a worker must have their set number of cards to prevent theft within the job site. Our last recommendation is to have more detailed foreman meetings at the beginning of the workday and plan out exactly which tools are expected to be used so the gang box can be kept locked during working hours. Thank you for watching.